Can you believe this little brush only takes 6 steps to model in Fusion 360? And the best part is, it requires 0 external supports for 3D printing. In this video, I'll show you how to model and print it step by step. Before modeling, let's look at the sketch for our brush. I've designed it to be quite compact for a quick test print. We'll input these dimensions into the parameter table for easy adjustments later. Go to the Modify panel and click Change Parameters. First, brush W for the width of the brush, 60 millimeters. Second, brush L for the length of the bristles, 20 millimeters. And brush D for the thickness of the brush, 7.6 millimeters. And the last one, handle L for the handle length, 30 millimeters. To better manage our resources, let's start by right-clicking the root directory in the browser and click New Component. Name it Brush. Now, create a sketch on the XY plane. Use the Rectangle tool and choose Center Rectangle. Starting from the origin, draw a rectangle. Enter handle L for the height and brush W for the width. Continuing with the Rectangle tool, create another one for the bristles. Set the height to brush L and the width to brush W. For the hanging hole, draw a smaller rectangle inside. Press D to use the Dimension tool. Set its height to 10 millimeters and the distance from the edges to 8 millimeters. Now, the sketch is fully defined. You should always aim for a fully defined sketch. This ensures the sketch stays exactly where it belongs and won't break if you decide to change dimensions later on. Okay, finish sketch. Press E for Extrude, select the handle profile, and pull it up. For the height, enter brush D. Right now, we have a very rough handle with sharp corners. Let's smooth it out. Press F for the fillet tool. Select the 4 edges of the hole and enter 4.5 millimeters. That looks much better for the hole in the handle. Select the 2 top edges of the handle and enter 10 millimeters. Add a small 0.8 millimeter fillet to the front face and apply a 2 millimeter fillet to the remaining edges. The handle looks great now, and those bottom fillets will prevent elephant's foot during printing. Now, let's move on to modeling the bristles. Don't worry, even though it looks complex, it only takes 2 steps to complete. Before we start modeling, let's look at the design. Each bristle is 0.8 millimeters wide, and there's a 1 millimeter gap between the bristles and the handle surface. In the vertical direction, we have a 1 millimeter gap between the bristles and the handle surface. The spacing between each layer is 1.6 millimeters, and the height of each bristle is 0.2 millimeters. We've designed a total of 4 layers, so the entire height of the brush is the 7.6 millimeters we talked about earlier. I'll explain why we chose these specific dimensions at the end of the video, along with some examples of failed prints. Now for the bristles. Go back and edit our first sketch in the timeline. Draw a small rectangle here, press D to use the Dimension tool, and set the width to 0.8 millimeters, height to brush L, and the distance from the edge to 1 millimeter. Okay, finish sketch. Press E to extrude, select the bristle, and set the start to offset with a distance of 1 millimeter. This creates the gap between the bristle and the handle surface. Then enter 0.2 millimeters for the distance and set the operation to join. This completes our very first bristle. Instead of modeling every single bristle, we'll use the rectangular pattern tool under Create panel. Set the object type to Features and select our bristle extrusion in the timeline. For the direction, select the x-axis. Set the distance type to Extent. The distance will be brush W minus 1 millimeter on each side, and then minus the bristle width of 0.8. For the quantity, let's enter 40 for now. It looks good, but you can always adjust this number to change the density of the bristles. Now we have a full row. Since we have 4 layers of bristles, let's continue under axis 2. Set the quantity to 4. The distance is 7.6 minus the 1 millimeter gaps at each side, and then minus 1 bristle thickness of 0.2. Click OK. That looks great. At this point, the brush itself is complete, but we've got a big problem if we want to print this. See here? These bristles are completely floating. Adding supports in the slicer would be a nightmare. I can't even imagine trying to pick them all out. Instead, we're going to use a bridging trick. We'll add a sacrificial block for the bristles to land on. Let's jump back into our sketch. Right below the bristles, draw a rectangle. 10 millimeters for the height, and brush, W, for the width. Okay, now press E to extrude. Change the extent type to object, and select the top surface of the highest bristle. Make sure the operation is set to join. And just like that, we've created a clean path for bridging. We'll just snip this extra block off once the print is done. Here's a quick breakdown of the physics. In 3D printing, bridging is when the nozzle extrudes plastic across 2 points in midair. This block we just built acts as a temporary platform for every layer of bristles, so we don't need a single piece of external support. One thing you need to watch out for: if the span is too long, the bridge might sag or fail, but since our span is well under 10 centimeters, it'll work perfectly. If you're still wondering how that works, just hang tight. It'll all make sense once you see it on the build plate. This model and the Fusion 360F 3D source file are available on MakerWorld. You are welcome to download and check the source file. Through this file, you can clearly see every step of the modeling and the parameters I've used. And through the parameters table under the Modify panel, you can easily modify these parameters and customize the dimensions. Okay, send to print. After 20 minutes of printing, we have our little brush. Look here, this is the block we created for bridging. We'll use a large scissors to snip it off. It feels a bit like giving the brush a haircut, and it is strangely satisfying. Look at these bristles. They are very clean and very soft if you run your fingers through them. We can notice that each strand has split into 2. This is because our line width is 0.4 millimeters, but the model is set to 0.8 millimeters. Once the bridging block is cut away, the ends split due to lack of adhesion. For a brush, this accidental splitting actually increases the surface area, making it softer and more effective at catching dust. Now, let's talk about why the bristles are designed this way. I prefer to make the bristle width a multiple of the line width. For a 0.4 line, a 0.8 bristle is exactly 2 lines. Take a look at this 1 millimeter wide bristle. You can see the gap fill between the 2 lines. This fill doesn't actually connect to the handle, which causes the strength at the root to drop suddenly. This makes the root very easy to snap off, especially with brittle materials like PLA. As for the height, setting it to 0.2 millimeters matches a standard layer height, so each bristle is exactly 1 layer thick. Look at this other brush. The bristle height is 0.4, and it's much stiffer, feels more like a wire sponge to me. So if you want softer bristles, 0.2 is just enough. In this video, I also want to share some printing tips with you, which is important in this case. First, I highly recommend using PETG for its flexibility and durability. PLA also works, but will be more brittle and more likely to snap. The second setting is crucial. In your slicer, I'm using Bamboo Studio here, go to the Speed tab and lower the bridge speed from the default 50 down to 25. Then, under Quality, go to Advanced and turn on Thick Bridges. Simply put, this increases the extrusion during bridging. If you don't optimize these 2 parameters, you'll end up with a print like this. See, because of under-extrusion and high speed, some of the bridge lines snapped, leading to a bigger mess. Okay, if you found this tutorial helpful, don't forget to like, subscribe, and share your thoughts in the comments. See you in the next one!